The first shape we're going to look at is just a generic trapezoid. A generic trapezoid is a quadrilateral with one pair of parallel sides. So that is the definition of a trapezoid. You have one pair of parallel sides. This particular trapezoid has nothing else special about it. It's just got one pair of parallel sides. So that means that when it comes to any special properties, there are none. So a generic trapezoid, the only thing special about it is that it has one pair of parallel sides. The next type of trapezoid that you're going to see is what we call a right trapezoid. The definition of a right trapezoid is that it is a trapezoid, so that means it's got one pair of parallel sides, and it has two right angles. So this is what my right trapezoid would look like. One pair of parallel sides and two right angles. And just like the generic trapezoid, there are no special properties for this trapezoid. The next trapezoid we're going to talk about is the isosceles trapezoid. So let's start with the definition. An isosceles trapezoid is a trapezoid, so that means we've got one pair of parallel sides with two pairs of congruent base angles. So the definition is using the idea that the base angles are congruent. So one pair of base angles would be down there. It's the angles formed by one of the parallel lines and the other two non-parallel sides. And the other pair of base angles is up here with the other parallel line and the non-parallel sides. So the definition for the isosceles trapezoid is that it's a trapezoid that has two pairs of congruent base angles. When we're thinking about isosceles triangles, we usually talk about how the isosceles triangle has two congruent sides. That is actually a property of the isosceles trapezoid. It's not the definition of it, it's a property of it. So here are my properties. The non-parallel sides are going to be congruent. So that means I've got one pair of congruent sides. The other property of my isosceles trapezoid is that the diagonals are congruent. So those diagonals are going to be exactly the same length. The other shapes we have that have congruent diagonals are rectangles and squares. Let's talk about the kite now. Kite. The definition of a kite is a quadrilateral with two pairs of adjacent congruent sides. So adjacent, remember that word just means they're next to each other. So the adjacent congruent sides in my kite would be those two sides and these two sides. When we were learning about parallelograms, the opposite sides were congruent. For a kite, the adjacent sides are congruent. Properties of a kite. The first property of a kite that we have is that the angles that are formed by the non-congruent sides are congruent. So here are my two non-congruent sides. The angle formed by them would be this angle right here. So the angles that are created by the non-congruent sides are going to be congruent to each other. The other angles between the congruent sides are not congruent to each other. Now let's talk about the diagonals. So our diagonals, we've got one of them that connects the non-congruent angles. And that diagonal is special because it does some stuff to the other parts of the kite. So the diagonal that connects the non-congruent angles is going to do some special things to us. So first of all, it is a perpendicular bisector of the other diagonal. It's a perpendicular bisector. That means it meets the other diagonal at a right angle. They're perpendicular to each other, and it cuts that other diagonal, the one that connects the congruent sides, into two equal parts. And remember, we discovered that because the kite has reflection symmetry. So I can fold it along that diagonal that connects the non-congruent angles, and I got a whole bunch of stuff that would be matching up. And one of them is the length of the diagonal from the congruent angles to the intersection point. So it's a perpendicular bisector of the diagonal that connects the two congruent angles. And the other thing that we learned about that diagonal is that it also bisects the non-congruent angles. So if I'm looking at my angles that are non-congruent, the diagonal is going to bisect that top angle, and it's going to bisect this bottom angle. So that diagonal that connects my non-congruent angles, it does some bisecting. It bisects the other diagonal, and it bisects the non-congruent angles. And it crosses the other diagonal at a 90-degree angle as well.